And we also talked about the third rule, which is the conservation of stereochemistry. So, when both diene and dienophile stereochemistry is basically retained in the reaction, we have a cis alkene here. So, when the Diels-Alder reaction proceeds, we end up with a product having the cis stereochemistry, and in this particular case we have the trans functional groups present on this particular alkene. So, after the Diels-Alder reaction is carried out, we end up with a product where these two substrates are in the trans orientation. In other words, the stereochemistry of the starting material is conserved or preserved in the final product. Similarly, if we look at the diene having substituents, like here we have a same cis arrangements here. So, we end up with a product having the cis orientation in the final product, and here we have the trans orientation of the two methyl groups. So, we end up with a product having the trans orientation in the final product also. And when we have a cyclic system, these two hydrogens are on the same side. In other words, we end up with a cis product as shown here. So, in the Diels-Alder reaction, the stereochemistry is conserved. Either the starting material, the diene's stereochemistry or the dienophile stereochemistry, both are conserved in the final product. So, how do we know the stereochemistry is conserved? If we look at the reaction mechanism, we can actually understand how the stereochemistry is conserved. So, here is a mechanism how the cycloaddition takes place. We have the alkene, that is the reactant as shown here. So, this R1 and R2, the blue color bonds are basically pointing towards the observer, and the pink color bonds are pointing away from the observer. Let us look at that. So, in this particular case, we have 3 bonds which are pointing towards the observer. This is the diene, and in the dienophile we have 2 alkyl groups which are pointing towards the observer. When these two approach each other, they actually approach in planar fashion, because sp2 carbons are basically planar. That is the reason the approach is also a planar one. When it approaches, whatever groups are pointing towards, they are actually pointing towards only. So, in the final step, if you assume that there is a plane at the bottom, there is a plane at the top, if those two are brought close to each other, that is how actually the reaction proceeds in the transition state. And when we look at the final product, whatever the groups which are pointing towards the observer still remains the same, and whatever are pointing away from the observer remains the same, because there is no change of stereochemistry. That is the reason this reaction leads to conservation of stereochemistry in the final product. So, let us look at the same thing in a 3-dimensional way, like molecular models. So, this is the alkene we are talking about. This is having the S-cis conformation, and this is our another dienophile which is going to add to the diene. So, here we have an oxygen as shown here in the red color, and both are having the cis orientation. These two groups are in the cis orientation, and this group and this methyl group are again in the cis orientation. So, these are approaching one above the other. So, there is also another way to represent the same thing. So, these are just joining two molecules together. In this particular case, whatever is pointing towards the observer remains the same, whatever is present here remains the same, whatever is pointing towards the observer also remains the same. These two just attach each other, and we end up with a cyclic product. When we look at the cyclic product, this is written in the chair conformation. So, in this particular case, the oxygen and the methyl group from the starting material, that is the carbon number 1 has the oxygen, carbon number 4 has the methyl group from the starting diene, is actually present in the same side as shown here. So, these two are from the cis orientation, this is retained in the final product. Similarly, carbon number 5 and 6, the two methyl groups are actually pointing towards the same side or the cis orientation, and if we look at the product 5 and 6 carbon, these two are actually pointing in the same direction or in the cis direction. So, this is how the stereochemistry is conserved in the product formation. And when we talk about the exo-endo rule, basically as we mentioned, this is the 4th rule of Diels-Alder reaction. When exo-endo products are possible, the endo product is formed in preference over exo product. So, here the Z group is basically the electron withdrawing group. When this alkene adds to the diene, this is the cyclic system which is formed. So, this is the preferred product in which the endo product is the preferred product. So, how do we decide what is the preferred product, endo or exo? With respect to the double bond, and we can actually see whether the hydrogen atom is towards it or away from that. Based on that, we can say whether it is a endo product or a exo product. With respect to the alkene, we decide.